Hi dear students, welcome to the next topic from gravitation. Last class we have discussed about the gravitational potential and today we are continuing the topic from gravitation. So write on the next heading, the relation between gravitational potential and gravitational field. So relation between gravitational potential is V and gravitational field is E. We know gravitational potential is a scalar quantity, gravitational field is a vector quantity. So we are going to learn about the relation and we are going to find out certain formula for this relations also. So what is called field? Field we have learned very detailedly. Okay, so gravitational field expressions we have learned and now we are continuing with the gravitational potential and the relations between them. So this is very important. So gravitational field E is equal to minus dV by dr. Remember this, in second year also we will learn in electrostatics chapter also, or electric charges, electrical potential and capacitance chapter. Okay. So E is equal to minus dV by dr is the formula. Suppose in case of x coordinate, if electric field is along the x direction, so the potential along the x direction is dou V divided by dou x, which means dV by dx. If you differentiate this one, you will get Ex. So this is with respect to r at a distance of r meter away. R meter away potential is given, you can find out the gravitational field intensity. Similarly, Ey is equal to minus of dou V by dou y. Similarly, Ez is equal to minus of dou V divided by dou Z. Okay. Suppose somebody is asking what is the value of gravitational field intensity, you will say Exi cap plus Ey j cap plus and Ez k cap. This is x coordinate, this is y coordinate and this is z coordinate. If we are writing a vector quantity like this one, here r, so here r is equal to xi plus yj plus zk. So whole together it is written as r. So if you split it individual terms, x term, y term, z term, then this is the formula. And gravitational field intensity E equal to Exi, Ey, Ez. What is Ex? Minus dou V by dou x. What is Ey? Minus dou V by dou y. What is Z? Minus dou V by dou Z. Two representation. Either will say dV by dx, dV by dz, or dV by dy, dV by dx, dV by dy, dV by dz. So you can say like this one, or you can say dou V, dou or dV, both are same, both are one and the same. So this expression is important. Okay, fine. So we are going to see a few questions with respect to this one. We will solve one example. Okay. So to get the more clarity onto this topic, so gravitational potential and gravitational field intensity relation, E is equal to minus dV by dr in a short way. So let's write the one example questions. Let V equal to 2 divided by x cube. Find the value of gravitational field. Find the value of gravitational field at x is equal to 6 meter. This was a question. What is given? Potential is given to you and you want to find out gravitational field. You know the relation between gravitational field E is equal to minus dV. This is with respect to, we'll put it as x cube. This is with respect to x. So dV by dx. You can also written as dou V by dou x. Random same ആണ്. dV by dx means differentiations. Dou V by dou x is also called differentiation. Both are same. There is no difference. So we'll take minus is taken outside. So d by dx of the differentiation of 2 by x cube. We are going to differentiate this one. So minus 2 is constant. So d by dx of 2 by x cube will come. So minus 2 by x cube. So 1 by x cube will be there. So 1 by x cube. 1 by x cube can be written as d by dx of x power minus 3. We know the general equations for x raised to n. X raised to n, d by dx of x raised to n equal to nx raised to n minus 1. So in this case, d by dx of x raised to minus 3. Denominator and the numerator minus of. So x raised to minus 3. So n is what? Minus 3. So minus 3 x raised to n minus 1. Minus 3 minus 1, which is minus 3 divided by minus 3 into x power minus 4, which can be written as, in the next stage, minus 3 by x power 4 we can return. So we'll substitute these values will be here. So what you will get? Minus 2 into, the differentiation is already calculated here over these sessions, and minus 3 into x power 4. Okay. So we'll go for the further simplification. Minus 2 into minus 3 is 6. 6 divided by x power 4. So balance steps I am writing will be here. So 6 divided by x power 4. Question is asking at x is equal to 6 meter. So 6 divided by 6 raised to 4. X and 6 is substituted. 6 raised to 4. So which means 1 by 6 cube, which is equal to 1 by 216. 6 cube is 216. So 216 is the value of gravitational field we have find out from the gravitational potential. Important. This model of question is really important. Okay. Fine. So this we got it. We will do one more questions similar to this concepts to make this concept will be very thorough and very clear. So if this is clear, please have a look into the previous topic in which you have forgot about gravitational field intensity. We have learned many terms, solid sphere, holosphere. I mean many things we have learned in the last sessions and all. So if you remember, of course it's well and good, else please recollect the topic. Okay, so let's go to the next question. So let v equal to x square plus y plus z cube. Find the value of E. Value of E means gravitational field at 1112. At 112. So what we need to find? X term, y term. So this is x coordinate. First one is x coordinate, second one is y coordinate, third one is z coordinate. So we are going to find out Ex. Ex means minus dv by dx. So minus d by dx of x square plus y plus z cube. So what we will get? X square plus y square. So we are differentiating with respect to x. So if you are differentiating with respect to x means the y, the differentiation of y is 0. Differentiation of x square is 2x. So a minus will be here. So minus taken outside, minus 2x. Differentiation d by dy by dx, it is 0. Differentiation of third one, z cube with respect to x. Is x in a we have to differentiate. We are not supposed to take any z or y term. So differentiation of z cube is also 0. So this is done. So answer is minus 2x. X in the coordinate is how much will be here? 1. So we'll substitute here minus 2 into 1, which is equal to minus 2. So x is over. We are going to do it for y. So what we get? Minus d by dy of the same formula, x square plus y plus z cube is equal to, minus is taken, y in which differentiate. So the differentiation of x square with respect to y, there is no y term, so it is 0. Here how many y term? Only one y. So differentiation of dy by dy is 1 plus differentiation of z cube is 0 with respect to y. So no y term. So answer will be is equal to minus 1 straight away. And next one is Ez term. Ez term means minus d by dz of x square plus y plus z cube. So differentiation of x square 0. So minus of 0 plus d by dz. So y 0. Z in a differentiation 3z square. So we know minus 3z square, the value of z square is 1. So minus 3z square and z square is 2. So minus 3 into z and we are substituting 2. So it become 4, will get minus 12. Minus 12 we got. Okay. So the value of the electric field. So the value of electric field is EXI plus EYJ plus and EZK. So we'll substitute these values. So minus 2 ex is minus 2. So minus 2 I cap vector, unit vector like the my vector term is I j k terms. So j is minus j and minus 12 k cap. Okay, if question is asking the modulus of E, magnitude of E, this is vector E. So if they are asking the modulus value, modulus scale means magnitude. Idinte square, idinte square, idinte square. So 3 terms in the square, minus 2 the square plus j and the coefficient minus 1. Appo adinte square, minus 1 square. K and the coefficient minus 12. So minus 12 square. So it become equal to root of 149. This is 144 and this is 4 and this is 1. Okay. So 5 plus 144 means 149. Okay. So answer is 149. So this is important. Okay. So hope you understood. V value is given and E value has to be find out. Perfect. Clear. Okay. So let's go further. So we are going to change the heading a little bit and we are going to learn the next topic or the next concepts. Okay, that is the intention over here, nothing else. So we'll see what are the things which are involved in this case. Okay, fine. So ring case. Okay. So what is ring? A ring whose mass is m, whose radius is r at a distance of x meter away. So a ring whose mass is m and at a distance of x meter away, gravitational potential is equal to minus gmx divided by root of r. So minus gmx divided by root of r square plus root of r square plus x square. This was a formula. So if you know V, we can easily to find out the value of E. So what is E is given as to us. So we know E is equal to minus d by dx. X means x direction. So Ex Vx. We are differentiating. This minus with this minus become plus. So we will simply written as d by dx of minus gmx divided by r square plus x square. So for a ring case, we are going to find out gravitational field intensity. So Vx is given, this minus and minus become plus as I told before. So the total value is equal to plus. So Ex will be equal to, what will come? Gm, okay, this is root. Gm is given. So minus Gm into, minus become plus. So d by dx of x divided by root of r square plus x square. This is the formula. So the gravitational potential is given and the gravitational field intensity value we need to be calculated. So this is what is the intentions over here. So how to find out the value of these terms, the value of these terms. There is no x over here, sorry for this, there is no x over here. Gravitational potential is only this, okay, there is no x, minus gm by root of r square plus x square. So remember this term, and what we need to be find out, we need to be find out the value of the gravitational field intensity. So the thing is like we need to integrate over here, not integrate, we need to differentiate over will be here. So here it is 1. So gm divided by d by dx of root of r square plus x square. So we are solving these steps. Okay, so gm is constant, gm into this I am taking to the numerator. So how it could be? It could be r square plus x square whole power minus 1 by 2. We are differentiating d by dx of these terms. Okay, so this become gm into, you can consider this as a single term. So 1 minus 1 by 2, minus 1 by 2 minus nx raised to n minus 1. So nx, x means r square plus x square, and x raised to n minus 1. So minus 1 by 2 minus 1, nx raised to n minus 1 into r square plus x square. First idine we are consider like an x power minus 2 formula consider. X power minus 2 means minus 1 by 2, x power minus 1 by 2 means minus 1 by 2, and x raised to n minus 1 into differentiation of this one, r square differentiation 0 with respect to x, x square differentiation is 2x. So these two and these two get cancels. So finally what we got, minus gmx whole divided by, this is minus 3 by 2 will come to the denominator. So it become r square plus x square whole power 3 by 2. And this is the expression for gravitational field intensity for a ring. If you know the potential, you can find out the value of E, or if you know E, you can also find out the value of potentials. So what is the equations? Because if you want to find out E, you have to use minus dV by dr. This is one way. In another way, differentiation is taken to the left hand side, it become integration. In maths we know if you are taking plus into other side, it become negative. If you are taking division into this side, it become multiplication. Similarly, integration and differentiation are the two contradictory operations. For that, if differentiations on the right side, if you take left hand side, become integration. So I can put it like this, v equal to differentiation is taken to this left side, or you can just rearrange this equation like this, minus dv is equal to E into dx. If I am integrating both the side, integral dv is equal to what? V, minus taken to the next side. Okay, here multiplied with the minus, here multiplied with the minus, both the side. LHS and RHS multiplied with minus. Minus into minus become plus. Integrate, so dv become V. That side, integrate, I'll keep the integration minus E into, instead of dx, we can written as dx, or we can written in this case dx. So this is the formula for this one. So don't forget about this minus, minus is still here. So if potential is given, if you want to find out gravitational field, then you have to differentiate the potential. If you want to find out the potential, gravitational field is given, you have to integrate the gravitational field so that you will get the gravitational potential. So that was the whole concept behind this chapter. No other complexities or nothing is there. Okay, fine. So let's go into this one. Fine. Okay, important, all these things whatever we have shown is important for entrance examinations point of view. Okay, never miss anything in the notebook, especially whatever we have learning. If you forget many concepts, of course please go back and take some time and read the concepts and come back. Read 1 or 2 times and then come back. Post the video, then you go back and you read whatever you have learned so far, and we'll see. Okay, next one, gravitational potential. Gravitational potential of a hollow sphere. Gravitational potential of a hollow sphere. So hollow sphere means we are going to calculate the gravitational potential at various points in a hollow sphere. Okay, so we already learnt about the gravitational I can say gravitational field intensity at various locations. Okay, gravitational field intensity at various locations of a hollow sphere, we already learnt about this one. So let's see the formula. So it is hollow sphere. Hollow means inside it is empty, nothing is there. So inside it is empty, and at a distance of r meter away, and at a distance of r outside, at a distance of r dash in the inside. So we have few points will be here. We have the outside one, and we have the surface one, and we have the inside one. So the gravitational field intensity at the outside is minus gm by r square. We already seen this one. And at this surface, maybe let me put it as out. At the surface is minus gm by capital R square. Maybe at inside, gravitational field intensity is equal to 0. So these things already we have seen in the previous lectures videos, and now we are going to see what is the potential value. So E is there, so we need to find out the potential. So we are going to find out V out, potential at outside. So V out will be equal to minus of, to find out potential from the field, what we have today, E out into dr. We have to differentiate, we have to integrate. E out in a, we have to integrate. Okay, so potentials we are integrating means, remember one thing, once we are integrating certain quantity, the potential at a point is always calculating. There is always, for example, let me consider like this one. For example, I have an x and y axis. So my reference point or my starting point is the origin. For example, I am saying I have an height of 5 feet and 7 inches or 8 inches, whatever say. So I am saying my height will be equal to 5 feet and 8 inches. Then I will say, like, I am starting the measurement from where? Ground. So ground is the reference point for me there. Similarly, for an xy axis, the origin is the reference point. So everything, whatever we are measuring will have a reference point. In case of a potential, reference point is infinity. So always we say potential means potential is calculated from one point to another point. So always starting from infinity. Infinity is somewhere away. So infinity to an outside point. So this is an outside point. Okay, always this is a surface point, and this is an inside point. So you always calculated from, so you see outside is far away from the center, then surface, then inside. So when you calculate the outside, you have to take the next point. Next point is where? Next point is at infinity. So I am saying infinity to outside, infinity to outside. So for infinity to outside, if you are taking, so what we have written previously will be here, integral dv I have written, right? You remember the equation just before I have written. We know E is equal to minus dv by dr. This equations I know. E is equal to minus dv. So if I am multiplying, it become E dr minus capital is equal to dv. So both sides we are integrating. So both, so same expression I make use of it will be here also. Okay, so this equation is correct. So integral dv is nothing but is equal to v, integration. Okay, so from where? Infinity to r. R means an outside point. So instead of out means I am writing as r. R is an outside point. So this can be written as v of r, sorry, v of r minus v of infinity. Final point minus initial point. Starting is an initial point, ending is a final point. So E out. what is the value of gravitational field intensity at outside? Minus gm by r square. So minus gm by r square. We are putting integral negative infinity r. So we need to solve this one. So v of r, v of infinity is 0. So v of r minus 0 is equal to, this minus and minus become plus. So integral gm divided by r square infinity to r. So we are integrating this one. So gm by this r can be written as r power minus 2 integral infinity to r. So what is the general formula of integration? Let's see. Integral x raised to n into dx. In case if you are not remembering, I am writing here. Integral x raised to n will be equal to x raised to n plus 1 divided by n plus 1. That is a formula. So for us will be here integral r power minus 2. So instead of this one, so r power minus 2 into dr. So dr, here also dr, here also dr, here also dr. So r raised to minus 2 plus 1 divided by minus 2 plus 1. So r power minus 1 and minus 1. Okay, this was the integral. We'll substitute these values over here. So gm divided by the value r power minus 1 will come to denominator. Minus is there. So minus 1 become minus gm. This will go to numerator. And r raised to minus 1. If you take into denominator 1 by r. Then what we have to apply? We have to apply the limit infinity to r. Infinity to r. Okay, infinity to r. Infinity to r means upper limit minus lower limit. So minus gm into upper limit 1 by r minus 1 by infinity. Upper limit, upper value minus lower value will substitute it. So minus gm divided by r minus gm by infinity is what? 0. So which become how I can say 1 by r minus 0. 1 by infinity is 0. So it become minus gm divided by r. So this is the value of gravitational potential at outside. So V out. So this is the value of outside gravitational potential, and the outside gravitational potential value we calculated from the inside the outside gravitational field. The gravitational field values already we have learned. Then I do certain integration process, then I will get gravitational potential. So remember this value minus gm by r square. This is very simple. There is no square. It is just minus gm divided by r. Okay, fine, good. So outside field we calculated. Next we go to surface. So surface is quite simple. Surface, if you do the same thing, but what is the difference for the surface? Difference for the surface become, instead of the small r square, what will come? Here capital R will come. So everywhere it become r square, it become capital R square into dr, capital R square into dr. So instead of small r, everywhere capital R will come. So surface is quite simple. It's straightforward. The same equations will come, but instead of small r, the same steps you can follow, but instead of the same small letter r, what we have to do? We have to use capital R. So I am not doing the derivation for that explicitly because it is the same thing as that of. So V surface. So now we got the two equations. We know V out equal to minus gm by small r. V surface is equal to minus gm divided by capital R. How you have done for small r, the same method will do for capital R. So this is simple. These two things we got it. And what is next? We need to find out gravitational field intensity. Gravitational field intensity is there for inside, it is 0, and we are going to find out potential at inside. So potential at inside means we are coming to an inside point. So the next nearby point is surface. So we are doing integral dv from surface to inside. Inside point is called r dash point. So surface is at what height? R distance away. So next immediate, so if you are will be here outside, the next immediate points will be there, infinity. If you are at surface, next immediate point is outside. If you are at inside, the next immediate point is surface. So r to r dash is equal to minus of integral capital R to small r is equal to E inside into d. We are calculating the inside gravitational potential. So to calculate inside gravity, if you are calculating outside, means outside is one point and the next immediate point is infinity. If you calculated inside, the next immediate point is surface. If you calculate surface, the next immediate point is outside. So for inside, you want to come to inside, but you are coming from surface. So r is the surface, surface to inside, surface to inside. If you are taking outside, means infinity to outside. If you are, suppose if you are deriving for out surface, means outside to surface. If you are deriving for inside, means surface to inside. So surface means r to inside, r to inside. Inside point is called r dash, r dash. Okay, so we know v in the differentiation with the integration, du v integration cancel out. So v of r dash, so v of final point minus initial point is equal to, what is the value of this one? 0. Inside it is completely 0. Okay, so v of r dash equal to v of r. V of r means what? Potential at surface, potential at a distance of r meter away. So which indicate potential at surface. What is the potential at surface? Minus gm by r, minus gm divided by r. Okay, so we derived all the values. Now we'll write a summary. Okay, so hope you understood this one. So pause the video and complete the notebook. Any stage, any doubt, yes, please come to me. Okay, so basic integration and very basic differentiations are available. So we find out gravitational potential. Now we just write the summary. So V out is equal to minus gm by r, and Vs will be equal to minus gm by capital R, and V inside is equal to minus gm divided by capital R. So we all have these three different values: minus gm by r, minus gm by capital R, minus gm divided by capital R. So gravitational field and gravitational potential, two set of values will be there for outside, surface and inside. So important things, important concepts. Okay, now we will do some graphical representation. So write on the heading for the hollow sphere. So next you can say graph. You can write a graph for what? For hollow sphere potential. For hollow sphere potential. For hollow sphere potential. Graph for hollow sphere potential. So let's draw the graph like this. Okay, we know it's a negative value, so outside. So if you consider a sphere like this one. Okay, so inside to surface, this is constant, inside to surface, minus gm by capital R, and then it is decreasing. So this is an outside point and it is decreasing, and V is proportional to outside, V is proportional to 1 by R. So this is the graph for the gravitational potential like this. Okay, so this is sphere representing, and this is a line of graph, and why it is coming at the bottom side? I mean bottom side means negative side, because all the equations will have a negative. So this is a positive v axis, this is a negative v axis. So values at surface, at inside, it is constant, so it is a straight line. Then the value is decreasing, so v is proportional to 1 by r. Okay, hope this is clear to you and you got some insight into this one also. Fine, perfect. And we are going to see what is next for a solid sphere, what is happening. So let's clean the board first and we'll see. Okay, these things we can keep, it will be here. Surface insert, this is very important. Entrance examinations point of view, you may get a graph. They will ask which of the following graphical representation is true, or some cases they will ask you about the equations or related stuffs will be there, you can expect. So gravitational potential of a solid sphere. What is the difference between solid sphere and hollow sphere? Solid means inside it is filled, inside it is not empty, inside there is no cavity, inside it is filled with a certain content. Okay, so again we have a solid, so we can say it is not empty. It is not empty. Inside point r dash, surface point r, outside point is small letter r. So these are the things. So E at outside is equal to minus gm by r square, and E at surface is equal to minus gm by r square, and E at inside is equal to, you remember this, many students will forget this one, minus gm into r dash divided by r cube. So this is important, never forget this one, because there is a high chance to what can I say, to forget about these things. Okay, so there are different things, so we will see one by one. Again we are going to derive the gravitational potentials for outside and surface and inside. So V at outside, first we will derive outside. If you get means surface is very easy, just to replace small r with the capital R. Okay, so outside if you are calculating means infinity to r, and this is given as dv is equal to integral infinity to r E outside into dr, one negative sign. Okay, so this we know, V of r minus V of infinity. V of infinity is called 0. So minus of integral minus gm divided by r square into dr. Let's continue here. Okay, so V of r, this is 0, which is equal to minus, and minus become plus. So it become gm divided by integral 1 by r square into d infinity to r, infinity to r. So V of r, so potential at a distance of r will be equal to gm divided by, so 1 by r square and the integral is minus r. So V minus 1 by r will come, 1 by r square integral. So just before we have seen, right, let me write integral 1 by r square into dr equal to integral r power minus 2 into dr, which is equal to r raised to x raised to n plus 1 divided by n plus 1. So r power minus 1, which is equal to minus 1 divided by r. So that what we got, minus gm will be here, and the integral become minus 1 by r, which is come here. So V of r will be equal to gm by r. Similarly I can say at surface. Okay, so V at surface, simple, small r na capital R ആയിട്ട് replace ചെയ്യണം. So V of capital R will be equal to minus gm divided by capital R. So remember these two equation, that is at the surface. Okay, this is the potential at surface, and the other one is potential at an inside point, potential at a surface point. Okay, that was the whole things which is available there. Next one, we need to find out what is the last one, potential at outside point. Outside point calculated, surface point calculated, one more things will be there, that is potential at inside point. Perfect. So to find out potential at inside, surface will be the next reference point. So inside kayina next immediate next irukkanathu surface aanu. So potential at inside, so we'll start from here, and minus of, not minus, integral dv from surface. Surface means capital R to inside R dash is equal to minus of integral capital R to R dash. R dash is an inside point, R is a surface point. E into dr. So we're substituting. So V of R dash minus V of R is equal to, previously in case of a hollow sphere E in equal to 0, but here it is not equal to 0. Capital R to small r dash E in is minus gm into r dash whole divided by r cube. Okay. So we'll keep the left hand side as such will be here. We will simplify a bit later. So capital R to R dash, minus and minus become plus. It become gm r dash divided by r cube. So we are going to solve this part will be here. Here gm by r cube it's constant, which is taken out of this integrations. Gm by r cube is taking coming out of the integrations. Add the things which is there, capital R to small dash r dash is equal to r dash. R dash is the only factors available. So how will you do? Gm divided by r cube into integral x. Integral x means x raised to n plus 1 divided by x raised to 1 plus 1. So r dash raised to 1 plus 1 divided by 1 plus 1 integral. What is the limit of integrations? Capital R to small letter r dash. Okay, so gm divided by r cube into, this is r dash square divided by 2, limit capital R to r dash. So we'll continue, and gm r cube and gm divided by r cube into upper limit minus lower limit. Upper limit r dash in badala will substitute r dash. So r dash square divided by 2 minus lower limit will substitute. So lower limit means r square divided by 2. Is this is expression? No, we need to find out V of r dash. So I have to continue. So you can pause the video. I need some space over here. Okay, so fine, perfectly fine. So I'll keep these statements over here. Then I need to continue. I need some further space over here. Okay, so I'll keep that equations over here. So what is my equation? Finally I got gm divided by r cube into r dash square by 2 minus r square divided by 2. This is what I got. I need to find out V of r dash. V of r dash means V of r is taken to the right hand side. So finally in this steps itself, what I can write? I can write V of capital R. V of capital R. V of capital R. So what is V of capital R? V of capital R means we are substituting gm divided by r square into r dash square divided by 2 minus r square divided by 2 plus V of r, potential at the surface, minus gm divided by capital R. That's all. Minus gm divided by capital R. Next what I am going to do will be here means I am taking gm by r cube common. I am taking gm by r cube is the formula in which is I am taking the common way. So what should I will get? I will get potential at r dash inside will equal to gm divided by r cube. Gm divided by r cube. So if you say gm divided by r will be here, gm divided by r will be. If I take gm by r cube outside, what things will come? 3 by 2 times of r square minus 1 by 2 times of r dash square. This is the potential at inside. You just to take gm by r cube here. R cube if you take will be here. You know this r cube is a factors which is there, gm by r cube. So gm by r cube if you are taken outside, minus r square by 2, r dash square by 2, here 1 by r. So minus gm by r cube is taken outside, it become 3 minus 3 by 2. So 3 by 2 r square minus 1 by 2 times of r square. Okay. Minus gm by r square is taken outside. Minus gm divided by r cube is taken outside. So in this cases what we are what formula we are getting, so that is leads to the answers. Okay, here there is no minus. Here we are taking minus gm by r cube outside. So if you consider like minus gm by r cube, if you have taken minus gm by r cube, then you think what is coming in the bracket, minus gm by r cube. Here there is no difference, r dash square by 2. So minus and minus become plus. So it will come in the second term, minus and minus become plus. Okay, and here what is coming? Okay, minus gm by r cube. Here r square divided by 2. So you can place it directly like r square by 2. But here what is coming extra? Here also you will come with the minus r square. So minus r square with the minus r square by 2. Minus 1 plus minus 1 by 2. Minus 3 by 2 r square into 1 by 2 raised to r dash square. Minus gm by r square veliyeduthu. So we will get potential at inside. Okay. So now we have the set of formulas will be there. So now we'll just summarize. I'm clearing the area. Now we'll just summarize what is coming over there. This is not complex. This is simple. This is a derivations part. But yeah, in entrance examinations point of view, remember, at least remember the formula. You don't want to by heart the derivation. But in case of somebody is asked how it is coming, you want to know. Okay, now I am representing as inside, and potential at surface is minus gm by r, and potential at outside will be equal to minus gm divided by small letter r. So all these things we got it. So we are writing. So potential at inside. Next one more additional point. Potential at center. Potential at center will be equal to r dash will be equal to 0, because r dash is a distance from here be here. So what you will get in this case? V is equal to minus gm divided by r cube into r, 3 by 2 times of r square. So r cube will get r cube and r square will get cancelled. So minus gm by r into 3 by 2 will come. Now we'll do the graphical representations for this r with respect to the potential changes with respect to the r. So this is a solid sphere. So exactly at the center we have minus 3 by 2 gm divided by r will be there. And once we come to the once we are going towards right side, and this is a surface point, and surface will have how much will be there? Minus gm divided surface minus gm by r is center minus 3 by 2 gm by r. So this is the next point over here. Then if you are going inside, it is further reducing. So the graph will be look like this one. So the graph will be look the center we have a gravitational potential and it is moving like this. So this is the graphical representation of gravitational potential for what sphere? Solid sphere. And if you see the one relation, gravitational potential at center, see potential at center is minus 3 by 2 gm by r. So I can say potential at surface is equal to 3 by 2 times, see potential at surface, this is potential at surface. Okay, so I can say the gm by r whole term is called potential at surface. So potential at center is equal to 3 by 2 times. What is this gm by r? Gm by r is called potential at surface. Potential at surface. So this is also an important inference from the definition or the formula book. So potential at the center. Center means minus 3 by 2 into gm by r. So other than the minus 3 by 2, other than the 3 by 2, what is minus gm by r is called Vs. So 3 by 2 into Vs. So potential at the center equal to 3 by 2 times of Vs. Okay. So today we have learned a big volume of things. The relation between gravitational potential and gravitational field intensity, and there are certain questions also we have seen, and we have seen the gravitational potential formula for a hollow sphere. At least remember outside what is the formula, surface what is the formula, and inside what is the formula, and the one graph. Similarly, gravitational potential for a solid sphere, outside, surface, inside, 3 formula definitely you have to remember. You have a high chance to get some question for the entrance examinations, and the graphical representations whatever we have done will be here. Hope you understood whatever I told to you. today there are little complexities will be there, I know, and you also feel that whatever we have studied so far, and there is a slightly little complexities in terms of the derivations. So please write it on your notebook or the sheet of papers and then practice it. Okay, so if you have you first learn one or two times, then you hide it away from you, then you started to work out on your own way, then you see you are finally getting the answers. If you've done couple of times, that is enough. Then mainly understand the formula and how the derivation methods are coming. It is not a kind of by heart, because in entrance examination you are not putting whatever you have learned in terms of derivation, but the concept is important. Okay, if you're calculating outside point, infinity minus outside. If you're calculating surface, means it's very simple. Outside na surface in the small r capital R which replace it. But if you calculate inside, means surface minus inside potential difference we are calculating, and based on that we are deriving this one. So one or two times if you are learn and then write, then you will get understand. So once you are writing, you may come up with certain mistakes, no problem. Just then again have a look into the notebook, then understand it and follow. Then again write one more time, unless until you are writing these derivations or this formula without any mistake. So up to that time you have to practice it. So this is quite easy. If you feel this is difficult, everybody who are going to write the examination have the same difficulty level. So please understand, when you study the difficult steps, your ranks will be keep on increasing, and it doesn't mean that you are going down. So if something is easy for you, everybody it is easy. Something is difficult for you, everybody it is difficult only. So we have to crack difficult questions, then only our rank will get a better rank in the final examination. Hope you understood, and thanks for listening to today's video lectures.